Hi Charles, I am Miss Becca, a TRCN certified math educator with over 12 years of teaching experience. How are you doing today? Oh, that's good to know. So, in this class, we will be solving systems of linear equations. Have you heard of linear equations before? Yes, a linear equation is an equation that the variable is raised to power 1. So let me share my screen with you. So in this class, we'll be solving systems of linear equations, and these are some examples of linear equations. Now, a system of linear equations is a set of two or more equations. I have explained what a linear equation is. Now, when we're now talking about a system of linear equations, it is a set of two or more equations that share the same variables. That is, they both share, if one is having x, the other is having x. If one is having y, the other is having y. And the goal of solving a system of linear equation is to find the values of the variables that satisfy all the equations. Look at this example now. This is a system of linear equations because it has two linear equations, x plus y equals to 10 and x minus y equals to 2. We will be solving both together, and you can see that both equations share the same variables. Now, the first method I will be using to solve a set of linear equations, we have different methods. The first method is the substitution method. Now, let's look at this example. How do we solve this? By substitution method. Now, let's go to the board. We have y equals 2x plus 1. This is the first equation. Let's call it equation 1. And then we have x plus y equals 10. Let's call this equation 2. We are to use substitution method. Now, we will substitute the value of y in the first equation. We will substitute it into the second equation. So wherever we see y in the second equation, we will be putting 2x plus 1, since y is 2x plus 1 from the first equation. So now let's solve. That means we'll be having, from the second equation, we'll be having x plus, since we're having more than one term here, let's open a bracket so that we have x plus 2x plus 1 equals 10. So that is the same thing as saying x plus y equals 10, because everything we have here is y. So we just replace it with y. So now let's solve further by opening the bracket so that we have x plus 2x plus 1 equals 10. X plus 2x would give 3x. Then when 1 goes to the other side, it becomes minus. So that means 10 minus 1 would give 9. Then we divide both sides by 3 so that x will be equal to 3. Now, don't forget that we are to solve for both variables. We solve for x equals to 3 now. Now we put the value of x in any of these equations. Let's use equation 2. Equation 2 says x plus y equals 10. So we'll put x equals 3. Wherever we see x, we put 3. So this means we will be having 3 plus y equals 10. And when 3 goes to the other side, we'll be having minus. So that means y equals 7. So from this equation now, from the given equation, x equals to 3 and then y equals 7. So that is what we refer to as the substitution method. Now, the second method is the elimination method. Just like the word says, elimination. So we will eliminate one of the variables to get the other one. Then we later substitute the value of the other one into the equation. Now we are to solve 2x plus 3y equals 12 and 4x minus 3y equals 6 using the elimination method. Let's go to the board now so that we have 2x plus 3y. We are using elimination method. What we have to do is that look at the upper one and look at the first equation and look at the second equation. If we have one variable that has the same coefficient, so we either add or we subtract. For this one now, we will just add equation 1 and 2. So we will add equation 1 and 2 such that we just put plus here. So 2x plus 4x will give 6x, then 3x plus this one has minus, that will be 3y minus 3y, that will become 0, so that we now have 12 plus 6, that is 18. Then we divide both sides by 6 so that x will be equal to 3. Now that we've gotten the value of x to be equal to 3, we have to look for the value of y by substituting x equals to 3 into any of the equation. Let's use equation 1 so that we have 2 into bracket 3, that is 2x plus 3y equals 12. So that means 3y will be equal to 12 minus, since 2 times 3 is 6, when it comes here, it becomes 6. So 3y will be equal to 6. Then we divide both sides by 3 so that y equals 2. So for that equation, for that set of linear equation, x equals to 3 and y equals 2. That is the second method for solving a system of linear equation. And then the third method is the graphical method. So how do we solve a system of linear equations using the graphical method? What we have to do is to plot both lines on a graph. Then the point where both lines intersect is the value of x and then the value of y. How do we solve this? Let's go to the board. So these are the two equations. You will notice that these equations have y equals to. So if you are given a set of linear equation that has that looks like the ones we solved before, all you have to first do is to make y the subject of the formula. So but in these given ones, y is already the subject of the formula. So what we have to do now is to make a table of value for each. Now let's make a table of value. You can pick any point that you want. So now for this one, we'll have something like this. Then let's pick values for x. Then we have 2x plus 1 here, and then let's have minus x plus 7 here. So let's start from minus 1. Let's use 0, 1, and let's use 2, and let's use 3, so that when x is minus 1, what will be the value of y? This is y, don't forget, this is y, this is y, y equals. So now when x is minus 1, what will be the value of y here? Then we have 2 times minus 1, that will be minus 2. Then minus 2 plus 1 would give minus 1. So here we have minus 1. When x is 0, this will become 0, so this value will be 1. When x is 1, this will become 2 plus 1, so this will be 3. When x is 2, 2 times 2 is 4, 4 plus 1 is 5. Then when x is 3, 3 times 2 is 6, 6 plus 1 is 7. Then for the second one too, we have minus x plus 7. So when x is minus 1, minus times minus will be plus, so that will be 1 plus 7. 1 plus 7 will give 8. And then when x is 0, we will have 7. When x is 1, that will be minus 1 plus 7, that will be 6. When x is 2, that will be minus 2 plus 7, that will be 5. And when x is 3, that will be minus 3 plus 7, and that will be 4. Now let's plot the graph. We have this now. Let's plot the graph. Let's sketch the graph such that our graph looks like this. We have more of positive values, so we don't need more of negative. So let's bring our x-axis here, since our y-axis has more of positive numbers. So let's have let's say we have 1 here. Let's use 2, 2, 4, 6, 8, 10. So we are using the interval of 2, and then we have minus 2 here. And then let's say we have, for x, let's use 1, so that we have 1, 2, 3, and then we have minus 1 here. So for the first one, when x is minus 1, y is minus 1. So that means that point will be somewhere here. For the second one, When x is 0, y is 1. When x is 0, y is 1. That will be somewhere here. Then when x is 1, y is 3. That will be somewhere here. When x is 2, y is 5. That will be somewhere here. Then when x is 3, y is 7. That will be somewhere here. So this line now will look like this. Don't mind my drawing. So this is the line for y equals 2x plus 1. Now let's sketch the line for minus x plus 7. So when x is minus 1, y is 8. That will be here. When x is 0, y is 7, 0, 7. When x is 1, y is 6. That will be here. When x is 1 and when x is 2, y is 5. That will be here. You can see the point they are meeting now. And when x is 3, y is 4. This one will be here. Now we join the points together. So this is the line for y equals minus x plus 7. You see that this is the point where they meet. They both meet. The both lines meet at this point. They meet at the point where x is 2 and then y is 5. So that means x equals to 2 and then y equals to 5. So that is how to solve a system of linear equation using graphical method. Let's solve a real world problem that involves a system of linear equation. The question says a class sells 30 tickets and earns $6,000. Adult tickets cost $300 each. Student tickets cost $150 each. How many of each ticket were sold? That means for the total of 30 tickets that was sold, we have adults and we have student tickets. So now that means we have student tickets, the class sold student ticket plus adult ticket, and that will give 30. First, let's say let x represent student ticket so that we will not mix it up, and then y represent adult ticket. So from the question, x plus y, there was a total sales of 30 tickets. That means adult ticket plus student ticket plus adult ticket will give 30 tickets. Now adult ticket cost $30 each and student ticket cost $150 each. So that means we don't know the number of student tickets that was sold. So that means $150 times the number of student tickets that was sold plus $300, I think. Yes, $300 times the number of adult tickets that was sold would give $6,000. So this is equation 1 and this is equation 2. So once you've translated your word problem into the equation, then you can use any method. You can either use the substitution method or the elimination method to solve further. So here now we can just use substitution method so that x will be equal to 30 minus y. So if x equals to 30 minus y, then you substitute it into this equation and then you get the number of student tickets and also you get the number of adult tickets. So what I am more concerned about in this real world example is to explain how to translate the word problem into um into a system of linear equations. Now you are to practice these questions. The first one is x plus y equals 8, x minus y equals 2, and the second one is 2x plus y equals 7, 3x minus y equals 8. Use any method. You can use elimination method for one and use substitution method for one. You can use graphical method to solve them. And here are the key takeaway from this class. You use substitution when one variable is isolated. For example, even when this variable is not isolated, you can isolate it yourself. For example, this one that we did now, you can see that the variable was not isolated, but we isolated it ourselves because some questions will not be isolated and you will be asked to isolate. You will have to isolate it yourself if you want to use substitution method. And then you use elimination to cancel variables easily, just like we did here. We use elimination method to cancel out y. We use elimination method to cancel this y variable here. And the third one is graphing gives a quick visual, but it is not always precise. And system of equations are very useful in real life, just like we see in this word problem. You see that this is a real life, real world application. So system of linear equation is very useful in real life. So thank you for your participation. Once again, I'm Miss Becca, your virtual math tutor.